Okay, thank you for watching this video. It's a new year. This worksheet, I'm hoping that you can recall majority of the problems on here, but if you're struggling with any of the problems, I'm hoping you're willing to watch this and try to learn. So this first problem, it's a problem that you've done in Algebra 1. It's the classes give 2 points, find the slope. Okay, now you could actually graph these points and see how steep this line would be. But we have a simple formula which just tells us to take the differences in our y's over the differences in our x's. So it doesn't matter which y value you start with which either -1 or -7. A lot of students seem to like to take the one that's on the right, but it doesn't matter if I pick this point up and move it over to the side, the slope doesn't change. So, but I'm going to write -7 minus, now be careful with minusing a negative, -1. So negative this y value minus this y value. And then underneath, I must put the corresponding input. So I must start with -8, and I'm going to subtract a 2. So this should be a simple calculation. Hopefully you don't need a calculator for this. You're going to have a -6 up top, and then on the bottom, you're going to have a -10. Hopefully you realize negative divided by a negative, it's a positive. So if you would graph these points, the line would be going uphill, left to right. But that does reduce to 3/5. Okay, so answer number 1 is 3/5. Okay, so for here, I'm asking you to graph a linear situation. So right now, this is known as standard form. When your x, your input, and your output, the y value are on the same side of the equal sign, it's known as standard form. So most of you are used to y equals mx plus b. So in this case, it would be really easy to switch over in that form. So all I need to do is bring this 2x over to the other side by subtracting 2x. So really the same line is really -2x plus 5. And I'm hoping that you'll recall from Algebra 1, when it's in this form, we have a starting amount, which is in this case is 5. That's your y-intercept. So I'm going to put a dot at 0, 5. And I know that this line goes downhill, and the number in front of your x is the rate of change, the slope. It's going down at a rate of down 2 over 1. Okay. Another way you could have done this is you could have just picked an input. I could plug in a 1 here and calculate the y value. So if you plugged in a 1, -2 plus 5 is going to be a 3, and you would have the point 1, 3. Okay. So there's my line. I'll graph one more point. I'll do down 2 over 1. So again, if you would have plugged in a 2, you would have an outcome of 1. That's all graphing is. It's inputs and outputs. So this line goes down forever. Okay. The next problem, we're now writing the rule. Okay, so to write a rule, the linear rule, you need to know the starting amount, which is really your y-intercept. So I know that it's crossing the y-axis, which we call a b, at -1. I need 2 nice dots. So I have this dot, and it looks like, you have to be careful here, it looks like it's crossing at 4, 0. So the slope of this is just up 1 over 4. So the slope, which we call an m, hopefully you recall all this, is up 1 over 4. Put everything together, 1/4 x minus 1 is the rule. Okay? So here we're actually solving a system. So a system is 2 or more equations. We're going to get to this in this first chapter, a system that has 3 equations and 3 unknowns. So right here is just 2 linear situations, and we're just going to graph both lines on the same graph, and hopefully we can find a nice, neat point of intersection. So I have a dot at 3. This first line up here has a slope of up 2 over 3. So I'm going to count up 2 dots and over 1, 2, 3, put a dot. I'm also going to go down 2 and to the left 1, 2, 3. Same line. There's the first line. That's how easy it should be to graph a line. So for the next one, has a starting point of -4. So I'm down here. Now this is going to go downhill. Now I don't really have enough room to count down 5 and to the right 3. So I'm going to count up 5. 1, 2, 3, 4, 5, and over 3. 1, 2, 3. It's this dot. That's my solution. This is the point right here that we have in common. So we want to name it. It's -3. So it's 3 units to the left, 1 unit up. And that's my solution. You would plug in your x, you would get this y. It works for both conditions. Okay. Question number 4. This is where we're solving a system, which I'm hoping you remember, by the substitution method. So again, I know you learned this in Algebra 1, but it's a matter of hopefully jogging your memory. And when you're doing this, I want you to show all the work. So with substitution, it's always nice when you already have a variable solved for. So this y is equal to this expression. So the fact that we already have y by itself, we didn't have to work to do that. Sometimes you have to solve for a letter, but in this case, I can substitute it right into the other equation. And what this is going to do for us is it's going to allow us to have an equation with just x's. So let me show the substitution. First part of this is -5x minus 2 times y, but instead of a y, we're going to put what y is equal to. It's equal to -3x plus 15. And the rest of this equation is equal to -25. So I'm hoping you have the skills to be able to solve this. It's a pretty simple equation to solve. It's -5x. I'm going to distribute. So a lot of mistakes can occur with signs. A negative times a negative is a positive, and a -2 times 15 is -30. So on this side, when I combine these, I just have an x. And then what I'm going to do is add a 30 right away. So when I add this 30, I know my x value is a 5. Okay, now again, we need an order pair. I need the x. Don't stop here. Found x. X is correct. But I also need to know the y value, which should be easy. Now that I know that x is a 5, I can do this calculation pretty quickly. It's going to be -15 plus 15, which is a 0. So 5, 0 is our solution. Okay? So then you also learned another method to solve a system, and that's the elimination method. That's where we went opposite. So I have 2 choices. I could get my x's to be opposites, or I can get my y's to be opposite. So if I wanted my x's based on these numbers, I could turn this x into a -9x by multiplying everything in the bottom equation by -9. For the y's, I can turn this 4y into a -12y if I multiply by -3. So to me, it seems easier to multiply by -3. So I'm going to just multiply everything by -3. So the top equation, I don't need to change. Now, sometimes with systems, we have to multiply the top and bottom by certain numbers to get opposites. So in this case, I can just multiply the bottom by -3. So when we do that, we're going to end up with, can I do that in my head? I believe it's going to be 51, but I'm just going to double check. I don't trust my old man brain, but it is 51. Okay, so -17 times 3 is +51. When you add your columns, you're going to have 6x. The y's cancel out. And when you add the numbers, you're going to get a 42. Okay, so then the last move is simply to divide by 6. And now we know half our answer. We know that x is going to be a 7. So then it's a matter of quickly substituting this in. So I can plug it into the top or the bottom equation. The bottom looks a little bit easier, but it doesn't matter. And I'm going to solve for y. So in this case, I'm going to subtract a 7. 4y equals -24. I'm going to divide by 4, and I'm going to get -6. So 7, -6 is my solution. Okay? So then the next skill I want you to remember is how we combine like terms. Okay? So when we're adding, we don't need a check. This set of the parentheses are doing nothing. Okay? I can just drop the parentheses, And so you have to remember what a like term is. Definition of a like term, same variable, same exponent. So when I see this 4x squared, it's all by itself. I don't see any other x squared to combine it with. So I'm going to write that term first. Okay, so this, we're finished. And then I'm going to take my 2x and this plus 7x, and together we're going to get a 9x. So that takes care of those two terms, and we're left with just a constant of -6, and we are done. Okay. Now for subtraction, you definitely have to be a little bit more careful because I'm really adding the opposites. So this first set of terms stays the same. Don't change the 5x plus 11, but then it really, this 8x becomes a -8x. I can just write it as -8x, but that -9 or -9 becomes a +9. Okay, so now I can just combine my like terms. This is and again, if you need a calculator, you don't type in your x, you just type in what's known as a coefficient, and you take 5 minus 8 or 5 plus -8, you're going to get a -3. And then when you add your numbers, you're going to get a 20. And you're finished. Okay. Your definition of simplifying is get rid of parentheses, combine like terms. So these are unlike, you can't somehow get a 17x because they're not the same. Okay. So then the next part is to recall multiplying. So when you are multiplying, you're not worrying about like terms. I can multiply anything. I can take a 7x times an x squared, and we end up with a 7x cubed. Okay. When I look at this next part, 7 times 8 is 56. X times x is x squared. And then finally, minus, and then 7 times 4 is 28. And you're just left with an x. So that's the distributive property. It's called a monomial times a trinomial. One term times three terms. My final answer is a trinomial. Okay, so now this next part, I know a lot of you learned this with the box method. There's also something called FOIL. You are distributing twice. So here's how you learned it in Algebra 1. I'll review this. You made a box, put an X, you put a 9, you put an X, and you put a -5 there. You got an X squared. You got a -5X. 9 times X is 9X. And then 9 times -5 is -45. Okay, so I recall that box. Now I can simplify this. Final answer is x squared, and then this becomes a positive 4x, and then minus 45. So we're going to do this so often where I'm going to teach you something called FOIL. So maybe your Algebra 1 teachers mentioned FOIL, but in Algebra 2, we will do this without a box. We're going to take x times x, that's your first. Then we're going to take the x times what's on the outside. That's the O part, your outside. X times -5 is -5x, same thing that we saw in the box. Then we go with the I of the word FOIL is the inside. That's where you get your 9x. And then finally, the L of the FOIL is taken 9 times -5. And then you simplify, you're going to get the same answer. So again, we're going to learn several techniques to get the same answer. I'm concerned that we understand how to multiply properly. Okay. And then our last page, we have the reverse of multiplying. It's called factoring. It is something that I know you touched upon before you took your Keystone exams in Algebra 1. So this is something that I'll teach you this again. So if from this worksheet you say, I don't know any of this, we'll get to this and review this because factoring is a very important skill for Algebra 2. So one of the factoring techniques you learned is something called the GCF, looking for a common factor. It's the reverse of the distributive property. So when I'm looking at these terms, I know 2 fits into both those. And I also have the letter X in common. So I can put a 2X on the outside of parentheses. And if I have a 2x on the outside, I would need an x inside because 2x times x agrees with the 2x squared. The 20x means I need a 10 inside. So 2x times 10 agrees with the 20x. That is what factoring means. We're writing it as a multiplication. If you multiply, you're back to the original problem. You know you factored correctly. Okay? So then this one, this again, we could make a box, and you learn this with the box method, but I'm hoping that you're going to be willing to realize there's a lot of shortcuts that we're going to learn. So I'm going to start out with two sets of parentheses, and I'm locked in. Since it's just an x squared, I know it's x and x, because x times x is x squared. The other thing I know is whatever this number is and this number is a negative 36. So I know it has to be a plus and a minus. And then since there's no middle term, the outers and inners disappear, I know these two numbers will be the same. So I know what times what is 36. I know it has to be 6 and 6. Okay, and how we can check that? You do FOIL. X times x, x squared. Your outside and your inside are opposites. They disappear. That's why there's no middle term. And then 6 times negative 6 is negative 36. So it checks. It is finished. That's your factored answers. So doing that same process for this. Again, I'll teach you, I'll review the box method, how you learned it in Algebra 1, but this is a trinomial that can be split up pretty quickly. Okay, again, when it's just x squared, it has to be x and x. Okay, the next part is there's a positive 24. So whatever this number is times this has to be a positive 24. So the only way we can multiply two numbers to become positive is if the signs are the same. So in this case, I must have minus minus. And you say, why must they be minus minus? My middle term is negative 11x. So it basically comes down to these diamond problems. I know in Algebra 1, you solved lots of diamond problems where you had to think of, okay, what two numbers multiply to give me, in this case, 24, but add up to negative 11. I'm hoping you know your times tables, because this is where it could take a little bit of work, but eventually you'll know 8 times 3. Okay, so negative 8 times negative 3 is a 24, but then your outers and your inners, the negative 8x and the negative 3x, agrees with that negative 11x. So this is equivalent to this. Like I said, if you multiply it out, that's all factoring is. It's a reverse of multiplying. Okay, so the last two problems, I'm hoping you can recall this. A lot of you did this right before you took the Keystone, when you were looking at roots and simplifying square roots. We don't want to take a calculator. I don't want to know the decimal. I know it's close to a 10. I know the square root of 100 is 10. So the square root of 99 is going to be a number really close to a 10. That's not what I'm asking here. We're trying to find a perfect square that's a factor. So when I see 99, I know the square root of 9 times the square root of 11. And so hopefully, and again, I'll go through this. So this is supposed to jog our memories. When we actually learn this again in Algebra 2, I'll reteach all this, so that if you don't even know what a perfect square is, I'll go over it. We'll have a list of perfect squares on my board later in the year where you can refer to that list of a perfect square. But in this case, what times itself is 9? I know it's a 3. So I know root 99, and I'll show this on a calculator. So here's my calculator. I can take the square root of 99. Like I said, it's a number very close to 10. And I can prove that 3 root 11 is the same exact value. So in math, we like the simplified form of a radical. Okay, so 3 root 11 is the same as root 99. Okay, so the last thing I need you to remember, and again, some of you probably may or may have not have done this in geometry. If you had geometry, one of the last topics is a little bit of a trig unit, SOHCAHTOA. So if you don't remember SOHCAHTOA, not a big deal. We'll get to this year. Hopefully you remember the Pythagorean theorem. The Pythagorean theorem is the two shorter sides of your triangle, that's your A and B, A squared plus B squared equals C squared. So in this case, I'm going to find out that this 5 squared plus 12 squared equals C squared. So I'm going to take my calculator. I know 5 squared is 25, and I'm going to add 12 squared, which is plus 144. You're going to get 169. And that's what c squared is. So obviously this side can't be 169 inches. If this is just 12 inches, that's 5 inches. We have the last move is to find c, we take the square root. So the square root of 169 is just going to be a 13. Okay, so c is 13. So then what you need to realize to be able to answer sine, cosine, tangent, my angle is this angle right here. Okay, that's called theta. So that's the angle I need to look at. So the side farthest away from that angle is the opposite. Okay, the side next to it that's not the hypotenuse. The hypotenuse is the longest side. We've calculated that to be 13. That is your longest side. The side next to is called the adjacent. Okay, so now once you know this, it's real easy to then do sine, cosine, tangent. Okay, so now there's something called SOHCAHTOA to help you remember these little ratios. So the sine of some angle, we don't know the measurement of the angle, but I do know to calculate that. If I know the side opposite is 12 and the hypotenuse is 13, we could calculate that angle. So all I'm asking for is, though, the ratio, the comparison of the side. So in this case, opposite side to the hypotenuse. The cosine is the adjacent side. It's this 5 over the hypotenuse. And finally, the tangent. And again, if this is something you never fully understood, this is something we will touch again and we'll take trig to the next level then later on this year. We'll go through this and learn some other trig aspects. But tangent is the opposite. The OA part, the opposite is a value of 12. The adjacent is a 5. Okay, so there's all the answers. You need to just make sure you show that work, and then I'll give you points for submitting this. And then hopefully this will allow us to then get into our chapter 1 material. So thank you for watching. You didn't have to watch the whole thing. Hopefully you can skip around, and throughout the year I'll do several videos that you can skip around to parts that you need to watch for you to understand certain concepts. So again, thanks for watching. Take care, and I'm hoping for a great year in Algebra 2.